Hello, this is Mrs. Lopez. We are working on lesson 15, equations of graphs of proportional relationships involving fractions. This is grade 7, module 1. So we are putting together everything that we've learned about proportional relationship, about unit rates, about constant of proportionality, about the equations that we worked on, and putting it together with the graph that we are already know how to do. Uh, this is a conclusion, the concluding lesson in this module for now. We will get back to it later during the year, but for now, this is our concluding lesson, last lesson in this module 1. So we are just summarizing everything we know and putting it all together. All right, so let's go ahead and start with example 1, gourmet cooking. After taking a cooking class, you decide to make dinner for your family. The recipe calls for mushroom as a main ingredient. Using the graph below, complete the table and answer the questions. Okay, so we are looking at mushroom mix in our cooking. I love mushrooms. I don't know about you, but I love mushrooms. So this is actually a very good problem for me here. Um, I see here a graph and I see a table. Um, in the graph, one thing that I noticed is that I have weight of mushrooms and it's on x-axis. And so I can relate it to the table. Weight is our x, and the cost in dollars is our y. And this is our dependent variable. One thing that I noticed also on the graph that you should not do is when you are putting the coordinate points without parentheses. You always have to have parentheses around your coordinate points. This way it will be easier for you to see what numbers we have in our um, on our coordinate points. Because here we have mixed numbers, and this is very, very hard to see without having the parentheses around. So the question here is this relationship proportional, and how do you know? Well, I can look at the graph and I can see the straight line and I see that it starts from the origin. So I can conclude that the relationship is proportional because it's a straight line and it comes from the origin. So let's go ahead and write that down. The relationship is proportional because the graph shows a straight line that starts from the origin. We like complete sentences, so we are going to use complete sentences in all our answers. What is the unit rate for cost per pound? Um, I'm looking for cost per pound. So we have to have 1 pound and some sort of a number. Do we have that anywhere? I don't. It's actually something that I want to find out right here. Cost per pound. And actually, I do have this one right here. On X, I have 1, and that's the pound. And on the costs, I have 8, and that's the number of dollars. So I can actually say, without dividing 4 by 1 and 1/2 or 12 by 1 and 1/2, that I already have that, and it's right here, 1/8. 8. And you can actually write it a little bit more to explain a little more about it. You can say what it means in the context of the problem. It's $8 per pound of mushrooms. Okay, so now we need to write an equation to model this data. We have weight of mushrooms in W for weight, I guess, for X. And on Y, we have cost in dollars, and that is a C. So to our general formula is y equals kx. So now we need to put that formula into that situation, incorporating our variables. Y is the c equals constant of proportionality is the unit rate, 8. X is the weight of mushrooms is W. Our equation is complete. What ordered pair represents the unit rate and what does it mean? We actually already answered it. We saw it on the graph, we found it, so we can just write it all over again. The ordered pair is 1, 8, and it means that 1 pound of mushrooms costs $8. What does the ordered pair 216 mean in the context of this problem? 2 is the weight of the pounds in the pounds, and 16 is the number of dollars. So we have 2 pounds of mushrooms cost $16. If you could spend $10 on mushrooms, how many pounds could you buy? I noticed that we are still having trouble with using equations. So I really, really want you to work with those equations. We have C equals W, 8W. C equals 8W. So we are going to put the numbers instead of the letters, instead of the variables in this equation. So $10 goes instead of the cost. $10 equals 8W. How do I find W? W was multiplied by 8 to get 10. So I need to divide 10 by 8 to get the W. W equals 10 divided by 8. And instead of using a calculator, I can just simplify my fraction. I can divide it by 2, and I will get 5/4, which is 1 and 1/4, and that is in pounds. 1 and 1/4 pounds. What would be the cost of 30 pounds of mushrooms? Again, our formula is C equals AW. Right now we have 30 pounds, so that goes for W for the weight. And we have C equals 8 times 30. 8 times 3 is 24, so 8 times 30 is 240. C equals 240, and that is in dollars. Okay, pretty easy. So we can just fill in the table. We can see it from the graph. 216 and 18. Didn't do that part yet. So I just filled in the table with 216. We saw it in the graph. 216 is right here, and 18 is right here. So we're just filling in the graph. Okay. So now we have a different problem, 10K race, and that's actually the last one in this lesson. Later is homework. So let's go ahead and read it. Grace's mom ran a 5K in 1.5 hours last month. This month, she decided to run a 10K. Grace and her family want to support her at the finish line. Assuming she runs at the same rate as the 5K, how long will it take her to finish the race? If the race starts at 10 a.m., what time should they be at the finish line? Complete the table and graph the values below. Okay, so we have time in hours, we have distance in kilometers, and time in hours. So time in hours is our h, and it's our x on the x-axis. The distance in kilometers is d in kilometers and y-axis. The distance depends on the time, therefore it's a dependent variable. All right, so we have 5K in 1.5 hours. So we have 1.5 hours, 5K. And then we have 10K, and we know that it's the same rate. So we want to see what rate that is going to be, right? So we are going to find, instead of answering A, we are actually going to answer B first. We are going to find the unit rate of kilometers per hour. So we are going to divide 5 kilometers by 1.5 hours, which is 5 divided by 3 halves. We are multiplying it by 2/3, the reciprocal, 5 over 1 if we need to, and we get 10/3, which is 3 1/3 miles per hour. Not miles, sorry, kilometers. Kilometers per hour. 3 1/3 kilometers per hour. Okay. We are going to use that race to be able to use this rate, sorry, to be able to find all the distances here. So we are going to multiply every single time in hours by our 3 1/3 or 10/3. It will be easier to use it in improper fraction right away. So we are multiplying everything by 10/3 times 10/3 times 10/3 times 10/3 and times 10/3. Okay, so 0 times 10/3 is still a 0. Anything times 0 is 0. 1/2 times 10/3, we can simplify 10 and 2 by 5, by 2, and we will get 5 on the 10, and we will get 5/3, which is 1 2/3 kilometers. We can multiply 10 by 10/3, and we will get 10/3, which is 3 1/3. We can multiply 2 by 10/3, and we will get 20/3, which is 6 2/3. 2 1/2 times 10/3, which is 5/2, times 10/3. We can simplify 10 and 2 by 2, and we'll get 5 on the 10, which is 25/3, which is 8 1/3. And then we can multiply 3 by 10/3. We can simplify the 3's, and we will get 10. So we got the 10K. So now what time will Grace's mom finish the race? We can write in 3 hours. She will finish the race. The question itself sounds a little bit tricky. It's asking what time, since we don't know what time she started. Actually, no, it says here the time starts at 10 a.m. So we know it will take her 3 hours. 10 a.m. plus 3 hours. 10 a.m. plus 3 hours will get us to 1 p.m. 1 p.m. Sorry about that. It goes right here. Okay. Is the relationship proportional? Yes, it is proportional because we have the same unit rate. The relationship is proportional. We're going to write it right here. The relationship is proportional because the unit rate or the rate is constant. Write an equation to represent the situation. Since we have y equals kx, our general equation, and y is the distance in d, that will equal our k is 10/3. We'll just write 10/3. And our x is time in hours, and that's h. Our formula looks like d equals 10/3 h. What does 0.00 mean in the context of the problem? The point zero zero is in 0 hours, she can run 0 kilometers. In 0 hours, she can run 0 kilometers. We can say it better. She cannot run in no time. All right, so that will work as well. One thing that we didn't finish in this problem is we didn't do the graph yet. So we can go ahead and do the graph. The time in hours, we are going to start with 0. We have 0, 0. We are looking at the table to fill in the graph. In 1/2 hours, so we'll be right in the middle, 1/2, and we go to 1 and 2/3. So it will be almost 2. Almost 2. 1 will be somewhere in the middle between 0 and 2, and 2/3 will be like very close to the 2. 1 is 3 and 3/3. 3 and 3/3, so 3 is in the middle between 2 and 4, and 1/3 is going to be somewhere here. This graph is not going to be very, very accurate because it's very tricky to find thirds. So let's see, 1.5 is 5. 5 is right between 4 and 6. So somewhere here. In 2 hours, we have 6 and 2/3. 2 hours, 6. This is 7, so 2/3 will be somewhere right here. 2.5 hours, 8 and 1/3. 2.5 is here. 8 and 1/3 will be just after the 8. Not getting to the middle because middle is a 9, right? So somewhere here. And then we have last one, 3 hours is 10. This one is the easiest one. 10 hours is 10 is right here. And then we are going to take a ruler and we are going to draw the line. I don't have a ruler, so I'm just going to use some paper here to connect my points. My points are not exactly on the line, again, because it's very tricky to draw them all correctly. But I'm pretty close. The first one I made a mistake on. So 1 and 2/3 is like right here. But I was pretty close. All right, so we are done with lesson 15. Your job is to do the homework, and it's just, well, it's a couple pages here. It's pretty easy if you understood all of the 5 lessons, 11 through 15. I will see you in class in case you have any questions. Have a good night.